we need to obtain the value of derivative of y with respect to x whenever x and y are given in its parametric form. That means here x and y are depending on the parameter t. So let's find out. So we'll begin by starting with whatever functions we are given with. So here we have x equals to 3at divided by 1 plus t squared. And we have y given by 3at squared divided by 1 plus t squared. Now let's begin by taking the derivative of x with respect to t. So this will be equals to, so here we'll have to use the quotient rule. So we'll start with the denominator. We have 1 plus t squared. We will square it. And then in the numerator, we have 1 plus t squared. This will get multiplied to derivative with respect to t of 3at minus 3at times derivative with respect to t of 1 plus t squared. Fine. This will then become 1 plus t squared. So we have to take derivative of 3at. So 3a is a constant, so that can pull up the derivative. And t, derivative of t with respect to t, so it's going to be 1 minus 3at. So now we have derivative with respect to t of 1 plus t squared. Derivative of 1 being a constant, it will be 0, and derivative of t squared will be 2t whole divided by 1 plus t squared whole squared. So let's simplify the numerator. We have 3a multiplied to 1, so that's 3a, plus 3a multiplied to t squared, so that will be 3at squared. Minus, so here 3at times 2t will be 6at squared, whole thing divided by 1 plus t squared whole squared. Or simply put, we have 3a minus 6, 3at squared minus 6at squared will be 3at squared, whole thing divided by 1 plus t squared whole square. So this is the value of derivative of x with respect to t. So let's label this as equation number 1. Now we'll take the derivative of y with respect to t, and this is going to give us derivative of y with respect to t. So this will be equals to derivative with respect to t of 3at squared divided by 1 plus t squared, which will be also equals to 3a. The 3a is a constant. We only have to take the derivative with respect to t of t squared divided by 1 plus t squared. Fine. So let's find out the derivative. So this will be 3a. So we will consider the denominator. That will be 1 plus t squared whole squared. We'll start at the numerator. In the numerator, the first term will be 1 plus t squared, and it will be multiplied to derivative of the numerator t squared, which will be 2t, minus t squared multiplied to derivative of the denominator, that's 1 plus t squared, which will be 2t. So further simplification is going to give us 3a. So in the numerator, we have 2t plus 1 will be 2t, plus 2t times t squared will be 2t cubed, minus 2t times t squared will be 2t cubed, whole divided by 1 plus t squared whole squared. Now 2t cubed and negative 2t cubed gets cancelled out, and this gives us the value of derivative of y with respect to t, which will be equals to, so we have 3a multiplied to 2t, that will be 6 times at whole divided by 1 plus t squared whole squared. Let's label this as equation number 2. Now what we'll do, in order to find out the value of derivative of y with respect to x, all we have to do is divide equation number 2 with 1. That means we take derivative of y with respect to t and divide it with derivative of x with respect to t. Derivative of y, so that will be 6at divided by 1 plus t squared whole square. The divided by derivative of x with respect to t will be simply the reciprocal. One will be multiplying it to the reciprocal, which will be 1 plus t squared whole squared divided by 3a multiplied to 1 minus t squared. Fine. So here 1 plus t squared whole squared, this gets cancelled from both the numerator and the denominator. 3a times 2 is 6a. That means we have now 2t divided by 1 minus t squared. So this is the value of derivative of y with respect to x. And clearly we see here that the derivative is also in its parametric form. That means it's depending on the parameter t.